Hi, this is John Jeffords, and I'm demonstrating Lab 5. I'll be going over the general layout of the processor, and then I'll be showing the add operation and the subtract operation. So first off, for the general layout of the processor, we've got this read-only memory right here. All these buffers, we've got 8 of them, and then we can select basically this memory address selector starts out as 0, so it starts from this first buffer, and then this just continually goes through all of these buffers unless we set it like a custom address with this custom this address register. Then we can hop between them, and then this instruction decoder, once it receives a value of which instruction which instruction the read-only memory sends it, it will change which of these wires are either turned on or off using this decoder. And then these wires go into the ALU section. So you've got things like arithmetic, which will be the same values as this arithmetic logic wire. Even though they're not physically connected, they're connected through the name. So whenever this invert gets changed to 1 or 0, this one will keep the same value. And then we've got this storage. So whenever we're done with the add or subtract function, we'll store it in this register right here. So I'll show you the first program, which is the add program. The first step is this 0 operation. It basically just loads this accumulator down here. This is the accumulator. And then we're loading the value 3. It's just an arbitrary number to show off the add function. And then the 1 is the add opcode. 5 is another number we're going to be adding to the 3, so we'll get a value of 8. And then we've got 2, which is the storage opcode. And we've got 0, which makes it a store in this register instead of this register. We could also do 1 if we want to store it in this register. And then the 3 opcode is just to stop the program. So I'll demonstrate it right now. So this will move down to the second buffer. Put in the value of 3, and then we'll clock it. Now it's at 1, and then so it's going to be doing the add function next. Now it just did the add function, but now we're going to use the 5 value in the add function because it's part 2. This right here, this current step goes from 0 to 1, and it could go to 2 and 3, but we don't have any functions that are quite that big. I think we have one that goes to a third value, but that's for the storage. Anyway, so we're about to input number 5, and then we're going to store that value. Right now this register is at 0, but it should have 8 in it soon. And then we're selecting address 0 in a second. And then we've got this value of 8 that's about to be stored in this register. We'll run through the clock once more. And it has 8. And then we'll clock it once more to go through the value to the stop code. And then this X means that's stopped. Alright, for the subtract program, we'll use 5 and 3 again, but in a slightly different order. We'll do the 5 and then minus the 3, and then we need to change this from 1 to the opcode 6, which is for subtract. And everything else can stay the same. So I'm just going to clear it for good measure. Alright, so we're about to run this code right here. Clock it once, then go through 5, 6 to subtract. Then we're loading in 3. We're storing with 2. We're selecting this address right here. And then 2 is our result, and we're storing that. And then we're going to run 3. It'll show up as X's. But we have the correct result, which is 5 minus 3, it equals 2. All right, that's my circuit, and I'm going to end the video here. Have a good day.